So as the lever arm axis is moving up, it basically stops the weight from rotating. I was asked to see what happens if we actually stop or limit the swing on the teeter-totter, or the reciprocation on the teeter-totter, and I don't know how to explain it, but oh yeah, what did we do? We stuck some just a few washers on there to give it a little more mass, and I put a weight fish scale at the location of the rack and pinion, and I was generating a pull force of 30 pounds in the downward direction, and it was still oscillating. It did restrict the movement, but so I mean, there's not a lot of power coming out of the solenoid. There's just barely enough to keep the small weight rotating, which is causing the oscillation. And then you have the mechanical advantage. The lever arm between there and there is or the distance between the center pivot point and the rotating weight axis is approximately twice the distance between the center pivot and the rack and pinion. And as we, you can adjust the voltage and get some interesting results. Obviously, the higher the voltage setting, the faster the RPM, and that affects the reciprocation. Can you stop it? Yeah, you can stop it with your hand. So all the real force is coming from the gravity assisted power, which is the centrifugal force generated by the small rotating mass. But there's definitely enough you got to adjust the voltage down to get the rotation or the oscillation going back into the system. But it's definitely enough evidence to proceed to add the gear train and the rack and pinion and the generator. We'll be making modifications, increasing the cam duty cycle, to closer to 100%. We'll probably get around 80 or 90% on time. Other problems are mechanical. Adding lubrication to the system definitely improved performance. The linkage, it's not square. The solenoid is not square to the orbiting weight or the crankshaft. So it causes the linkage to walk to one side, and that adds friction. But we can add a ball joint at the crank location, and that should help resolve that problem. So it's not perfect. There are issues, but there's enough evidence to move forward on the project. We'll be adding more weight and finding out what the max weight is for the system. We're going to limit the power supply to approximately a 12-volt deep cell battery, and so that'll limit the current and the max RPM and that sort of thing. But it's coming along nicely, and I'm happy with the results so far. Thanks for watching. And if we grab onto the shaft, it's very easy to stop even if the cam is engaged. But the amplification or the increase in power or torque is really quite impressive for such a small weight orbiting at this RPM. Thanks for watching. Enjoy the day. Cheers. This is the amp scale. It's not really, like I said before in an earlier video, the Nyquist rate is, rather slow, so this isn't accurate. What's interesting is the way the voltage jumps around. Obviously, the back EMF is, sending something back into the power supply when that's happening. So, I'm not sure if there's a way to add a flyback diodes to a bidirectional solenoid circuit, but that'll be something for future development as well. Thanks for watching. Have a great day. Cheers.